Let's take a look at the PhET density simulation worksheet and go over some answers. And so we'll start working here. So for the data tables, obviously I'll take a look at that in your notebooks as well as the graphs. But let's focus now on the fill in the blank here. So for number one, density is calculated by dividing the mass by the volume. Number two, if an object has a high mass but a low volume, the density will be high. Number three, an object will float in water if its density is less than the density of water. Number four, a less dense object has less mass in a given volume compared to a denser object. And number five, by increasing the volume of an object while keeping the mass constant, the density will decrease. Okay, multiple choice. Choose the correct answer from the choices for each question. Number one, which of the following best describes the relationship between mass and density? The answer would be letter B. As mass increases, density increases. Number two, how can you decrease the density of an object? Answer is letter C, increase its mass while keeping volume constant. Number three, what happens to an object's density when both its mass and volume are doubled? B, the density remains the same. Because if we're gonna double each of those, so it's not gonna change the math that you use to divide mass over volume. Number four, if an object sinks in water, which of the following is true? Letter C, its density is greater than that of water. So when an object floats on top of water, its density is less than water. So whatever is more dense will go further down towards the center of Earth. Number five, which unit is typically used to measure density? And we're looking at this one right here. Sometimes, and you guys know this, sometimes we'll use grams over cm to the power of 3. But most importantly, recognizing that density has two units when we are measuring density. So there's got to be a mass and there's got to be a volume, so we need 2 units. For the open-ended questions, these might be a little different depending on how you're writing these. So number one, describe how the simulation helps you understand the relationship between mass, volume, and density. So just understanding that if mass is a numerator and volume is always a denominator, and that's giving us our density, depending on how much this goes up or down and how much this goes up or down, that's going to affect our density. Number two, using the simulation, what did you observe when you increased the volume of an object but kept the mass the same? The density would decrease. So if you have an object with some mass in it, and then you increase the volume, but you have the same amount of mass, that density there is lower. And mathematically we can prove that. And the last one, explain why understanding density is important in the real world. So one thing you could talk about is when we are thinking about boats in the water and keeping boats afloat, understanding the fact that density has a huge role in that. And that is that. And so I thought we would continue and just sort of go over the condensation lab answers as well. So let's just take a look at some of these for part one. So explain which cup had moisture on the outside of it. So if we are looking at the cups up here, if you took all the air out of the one in the bag, this cup here to the left is going to be the one that has moisture on the outside of it. So the cup outside the plastic bag. Number 2, why do you think this cup had more moisture on it? So when you have this cup up here outside of the bag, you have gas particles. You have gas in the air around here. And what happens is when the gas particles get close to the cup, the cold water and the ice cools those particles down. And when you cool those particles down, you go from a fast particle to a slow particle. And when particles slow down, you have the potential for those to go from a gas to a liquid. Because when you slow something down, that is when you have a state change happening. Just like when you speed up a liquid, you turn it into a gas. And so the cold water in that cup cooled down the gas particles, slowed them down, and they turned into a liquid, and they attached to the wall of the cup on the outside because particles are attracted to each other, especially when they're slowed down in liquid form and the solid form of the cup. Some people think that the moisture that appears on the outside of the cold cup of the water has leaked through the cup. That can't be true because what you should have done is sucked all the air out, sucked all of those gas particles there. They should not be present inside the bag, and therefore your cup should have been dry if you took out enough of the air. So in that scenario, what were you looking at for activity 2? Moving right along, let's take a look at number 1 here on part 2. After a couple minutes, what did you observe on the inside of the top of the cup? Scenario, you had, let's see, So in that situation, you should have just seen some moisture. So you had the cup like that. Well, you have one cup, and then you have another cup on top. Something like that. Yeah, you had the cups on top. Anyway, when you take this water and you add warm water in here, as the warm water speeds up, it turns into a gas, and then it should have lined the top of the cup up here. So that's just again your cup turning into the water in your cup turning into a gas, and then what happens when it reaches the top is it gets colder, and then it condenses on the inside of the top cup. Why did that happen? Again, it's all about just cooling and reducing the speed of particles. So if you have something hot or a gas, it's going to be going at high speeds. If you slow it down, it's going to turn into a liquid, and we call that condensation. And then the last thing is just looking at these cups here. And so the key here would, when you took the ice off of this cup, when you removed it, you should have lifted this cup up and seen the condensation on the inside of the cup up there. That would have been due to the cold ice cube cooling the gas on the inside here and then turning that into a liquid. So another condensation situation there. What else? The animation showed the molecules of the glass. Since the water molecules separated, why did the gas come together to form a liquid? So this is just again about cooling the water vapor down. Why do you think the cup with the ice has bigger drops of water on the inside than the cup without? Again, the ice cube there is cooling down the gas, and so you're going to get more gas turning into a liquid. All right, those are the answers for the density worksheet and lesson 2.2 on condensation.